I often say it's a good idea to start with u substitution. If we did, the u would equal the denominator, and then take the derivative of that, we'd have 2x plus 5. For u substitution to work, this thing right here, 2x plus 5 dx, would have to match this right here. And the only way that you can manipulate this is by multiplying or dividing by a constant. Since there's no way to multiply or divide by a constant and get this 2x plus 5 to turn into a 2x plus 6, the u substitution is not going to work. So we need to try something else. Well, since the denominator can be factored, we can use partial fractions. So, first of all, we need to do the algebra. Take a 2x plus 6, factor this, it would be an x plus 2 times x plus 3. That means that the original problem can be rewritten as two fractions, one with x plus 2 is the denominator, one with x plus 3 is the denominator. The numerators will be some numbers. For now, I'll call them a and b. Now, clear the fractions. Multiply everything by x plus 2 times x plus 3. And on this side, so over here, everything is going to cancel except for the 2x plus 6. Then we would have a times, so these cancel, a times x plus 3. And you don't need to multiply that out, you can just leave it factored like that. Over here we would have these cancel, b times x plus 2. Now you can pick numbers for x, like let x equal a negative 3. So I'm choosing a negative 3 so that it'll actually cancel this term. So if you use a negative 3, this is going to be negative 6, and positive 6 is 0. It's going to be a times, that would be 0, plus b times, if I use a negative 3, it's going to be a negative 3 and a positive 2, so that's negative 1. Consequently, what I have tells me that b is equal to 0. b is equal to 0, this term would be gone. Oh, I see. That means that I didn't even need that b. Interesting. Math can be so smart sometimes. Okay, then plug in another number so we could find out what a is supposed to equal. So if I use negative 2, this is going to be a negative 4 and 6, so that is 2. Use a negative 2 in here, and negative 2 and positive 3 is a 1, so a times 1. So it turns out that the a is at 2. So that means that the original problem, 2x plus 6 over x squared plus 5x plus 6, can actually be replaced with just an a, which is a 2, over, the a was over the x plus 2. Well, that makes it a lot simpler. And if you factor out the 2, you'll see that it's essentially just like 1 over x. So it turns out it is the natural log of x plus 2. And so that you don't take the log of a negative, we put that in absolute value, and there we have it.